What's up, math scholars? Mrs. Harp here, wishing you a happy Earth Day yesterday. Get out there and pick up some litter. These Jackson Township roads are disgustingly full of litter. I pick up litter on Fulton, pick up litter on High Mill, and it still looks terrible out there. So save the Earth, don't litter. All right, so who's excited? It's Monday. It's going to be warm today. 70 degrees. Woo! Sunshine, sunshine, sunshine. Okay. So I am looking for a volunteer who's a scholar at geometry and knows how and has already solved this problem. So who knows how and who has already solved this problem for 1 second? No one is good with geometry. This is bad. Okay, well, maybe I'll give a ticket out if you can help me decide whether I'm using sine, cosine, or tangent. Lexi. Tangent. Very good. So let's set this up. It would be tangent of theta equals opposite over adjacent, and 10 is opposite to theta, so we're going to go with 10 over 8. Now, I have several people sitting in this class that are in geometry right now. You do not know how to make this tangent disappear and solve for theta? Nope, you cannot divide by tangent. Nope, cannot use reciprocal. It's called a tangent inverse. You do that in geometry. I taught geometry. So that will cancel your tangent. You can't get rid of the tangent any other way. So in the calculator, everybody do this with me. Second tangent. That pulls up the tangent inverse. 10 divided by 8, which makes theta 51.34 degrees. Cool? All right. Today we're learning 9.4. Have your unit circle out and ready to refer to, and have your calculator out. Those are your two materials you need to have ready to rock. Alrighty, here's what I want you to write down from this slide. I want you to jot down that if you're using sine inverse, you'll be searching on your unit circle in quadrants 1 and 4. If you're using cosine inverse, you'll be searching on your unit circle in quadrants 1 and 2. It'll be like seek and find on the unit circle. It'll be fun. And then if you're doing inverse of tangent, you'll be looking on your unit circle for quadrants 1 and 4 again. Okay? So I kind of drew this up on the board, on my formula board, so you'll kind of know where to do your searching. And by searching in only these two quadrants, you'll be giving yourself one answer, one solution. That's why we're doing our searching where we're searching. We don't want two answers. Alrighty, so we're going to do a little seek and find game with our unit circle. On this very first one, we're doing cosine. So what quadrants will we be searching in? 1 and 2. So I kind of circle what quadrants I'm searching in, so I know. Now cosine is an x value. So we're basically searching and seeking and finding places that have x values of radical 3 over 2. And there should only be one place. Let's look. No. You found him. Did you find him? And we want our answer in radians and degrees, so you would just say that 30 degrees and pi over 6 both have cosine values of radical 3 over 2. Make sense? So we're limiting our search to quadrants 1 and 2, so we only get one solution, because we would have actually found another solution had we expanded our search. Yeah.
So would this be just like an easier way of doing radians to...
All right, the second one, we're going to be doing sine. So what quadrants will we be doing our search in? 1 and 4, very good. That would be about here. Now we are looking for places that have a y value, a sine value of 2. Huh? I love that she said that. It's a unit circle. It only has a radius of 1. So we're never going to find a number as large as 2, right? So there's really no solution. I looked in the book how they wrote that. They actually wrote the word undefined for the answer to this one. This looks like not a possibility. All right, we're back with our next example. We'll do a couple of these together. You can do a couple by yourself. Maybe we'll do the first 3 together. You do the last one by yourself. So number 1, we're doing sine. What quadrants will we be searching in? Quadrants 1 and 4. We want our sine value, in other words, our y value, to be radical 3 over 2. Say found it when you find it.
Found it.
Found it. It's right here, correct? Y value is radical 2 over 2, so 45 and pi over 4. 45 degrees, pi over 4 radians. All right. Let's try number 2. What quadrants do we search in for cosine? 1 and 2. 1 and 2. We're looking for a cosine value, in other words, an x value. That's 1/2. So yell out, found it. Let me find it.
Found it.
You did? Where's it at?
That's obviously at 60 degrees.
Right. 60 and pi over 3. Alright, try number 4 all by yourself, and then we'll come back and do 3 together. So I want you to do 4 all by yourself. I didn't hear anyone yell, found it. Did you guys find it? Is it at 330 and 11 pi over 6? Good. 330 degrees, 11 pi over 6. Because it's a negative 1/2, yeah. There's a negative there, and there's a negative there. It might be small and hard to see. Okay, so I want to do the tangent with you. What quadrants do you search for tangent in? 1 and 4 as well, but tangent requires a lot more thinking with your brain because tangent is y values divided by x values. So anytime you're going to be able to get a 1 or a negative 1, your x and y have to be the same exact number, right? So really the only possibility for us is either here or here. Which one of those would actually divide out to a negative 1? The bottom one, because one's negative and one's positive. So we're going to go with 315 and 7 pi over 4. Okay. All right. We've arrived at what I think would be the hardest type of problems of the day. You cannot look on your unit circle for this one because negative 5 over 8 is not a coordinate on the unit circle. So any ideas how I could solve this equation for theta? I'll give you a hint. We did this in the warm-up today. Do a sine inverse on both sides. Sine inverse here would cancel the sine. You have to do it on this side as well. And then for these problems, we're going to round these to the nearest degree just to help us with our calculations in a minute or two. So second sine, negative 5 over 8. Everybody type that in your calculator. Second sine, negative 5 over 8. We're going to round to the nearest degree. So I'm going to round that to negative 39 degrees. Now, that's not our final answer. I should not have even circled that. That's not our final answer. Okay. What I'm going to do is I'm going to sketch that negative 39 degrees on my circle to get a mental image on where he lives at. So we all agree he lives probably about here, negative 39 degrees. So that reference angle is 39 degrees. We're going to be using reference angles today. So hopefully you remember how those work. Now, they're going to tell you where they actually want your final answer to live. Right now, our answer is living in quadrant 4. That's not where they want their answer to live. They want their answer to live between 180 and 270. So they actually want the answer to live in quadrant 3. So we're going to use a reflection and a reference angle to find our final position of our final answer. Okay? So if I would reflect my negative 39 over to quadrant 3, it'd be about here. Do you agree? So it would also have a reference angle right here of 39 degrees. So to find that blue dot, to find his actual position, I'll do 180 plus 39. That's why we did all that work with reference angles last week, so you'll understand that concept. So 219 is your final answer. Let me go just put a star by it since I've already circled a few other things on the slide. 219. Okay? Makes sense? And 219 would have the equal y value. That's the negative 39 because they're equally below the y-axis. Okay? I'll hit pause if you have. All right, here's another practice one. Cosine theta equals 0.4. We want our final answer between 270 and 360. What quadrant would that be? Quadrant 4 is where we want our final answer. Alright, so who remembers how to start this? What am I going to do to both sides? cosine inverse. Oh, I didn't know how my board was going to write up here, but it's cosine inverse on both sides. I know. I'm telling you, my board doesn't write really well up in the corners. So we're going to cosine inverse this side. We're going to cosine inverse this side. And round to the nearest degree just to help us with our reference angle calculations. Cosine inverse is 0.4. So 66 degrees sound okay? Okay, we're going to do a quick sketch on where 66 degrees lives. Do you know where it lives? What quadrant? Quadrant 1. So 66 degrees would probably be about here. And its reference angle measurement would be at 66. But we want our final answer down here between 270 and 360. We're going to do a reflection and a reference angle. So let's reflect our blue dot down to quadrant 4. It would be here. It would also have a reference angle of 66 degrees. So how do I find the position of that number? What would I type in? No, 270 plus 66 would not be correct. 360 minus 66. Does that make sense? No? Reference angles are always kind of based off your x-axis. Just kind of remember that. So never use your 90 or your 270. So 360 minus 66 is 294. That would be your final answer. All right, we'll do this one together, and how about the next one after this you try by yourself. So our first tangent problem is exciting. Tangent of theta equals 2.1. What quadrant do we want our final answer to live in? Quadrant 3, because 180 would be here and 270 would be here. All right, let's do a tangent inverse on both sides. Oh, excuse me. So tangent inverse both sides. Tangent inverse 2.1. We're all typing this in our calculator back there. We're all typing this in our calculator back there. Ethan, we're typing this in our calculator right now? All right, I'm recording, and we did a tangent inverse of 2.1, and we got our angle to be 65 degrees. Everybody okay with the tangent inverse button?
You rounded up.
I've been rounding to the nearest degree just to help our calculations with our reference angle stuff.
Okay.
Yep.
64.5.
64.5 would round up to 65, so we're good.
Thank you.
Okay, so let's sketch where 65 degrees would be. Probably about here, right? Now, it has a reference angle of 65 degrees. Where do we want our final answer to be? What quadrant? Quadrant 3. That's awkward to reflect this down to quadrant 3, isn't it? No, quadrant 3, because it's between 180 and 270 is where they want their theta to live. So I'm going to actually reflect this twice. Here, it would live approximately here. I'm not going to draw that in. But then I'm going to reflect it down here. Here, it would live here. Now, do you know how big his reference angle would be? Because reference angles are always with the x-axis. It'd also be 65. You see that vertical angle? Geometry people, we got a vertical angle there.
Yeah.
Yes.
Could you reflect it over, what is it, like the negative x, y, or y x?
Yeah, that would work. That little diagonal line. So to do the calculation, I would do 180, and then would I add or subtract that 65? Add. So 245 is your final answer. Just put a star by it. All right, we're going to have everybody try this all by yourselves. So if you're at home watching your video, click pause and try it. I'm going to be recording. All right, so I did a sine inverse on both sides, found my theta to be a negative 13 degrees. That makes that a reference angle right there about a 13 degrees. Where do they want our final answer to live? Right in that quadrant. But they want the value to be between 270 and 360. So don't have to reflect anywhere, but I should do some sort of calculation.
360
Add a 360. So just add a 360 to that negative 13. It's 346. Or 347. 347. Okay. All right, we do have to move along to some triangle problems. Okay. We'll do one together, and if there is time, you can do the graduation problem. If we run out of time, then it's fine. You don't have to do it. Okay. So, we ready to rock? We're still typing? Ready? All right, so we are going to find, we'll actually go to this one next. Actually, we'll go to this one next. These are all problems my last class did, and you guys are running out of time. It's okay. Here, we're going to go ahead and solve the whole entire triangle. I wanted to jump to a problem where there's more than one task. So you're solving for theta, you're solving for alpha, both missing angles, and you're solving for x. So this would be your right angle. And again, you have a choice of what you want to start with. Do you want to start by solving for theta? Alpha? Or start by solving for alpha?
You gotta start with alpha.
It doesn't matter. You can start with any of the three. Doesn't matter. Let's solve for alpha first. So to do alpha, I would definitely go with tangent, because all I have available to me right now is opposite and adjacent. So since alpha lives here, 5 is opposite, 22 is adjacent. 15, I'm sorry. So at that point, you would do a what? A tan inverse on both sides. So I would tan inverse my 15 over 22. Uh, 34.28. Let's just round it to 34 degrees. If you want to do decimals, you can do decimals. I'm just doing this for ease of calculations. All triangles add up to how many degrees? So at this point, I could do my 180 minus my 34 minus my 90. 56. Some of you can do these in your head. And then how would I finish the triangle off and solve for x? Pythagorean theorems. These aren't bad at all. 15 squared, 22 squared equals x squared. You already got it?
Square root of 709.
Oh, 709. And then we're going to square root the 709. Did you add that up in your head?
Huh? What?
Did you add 15 squared and 22 squared in your head?
No, I did.
Oh,
22
okay,
squared,
I was like-
but I did 15 squared.
Okay.
I know up to 15.
You know it's up to 15. 26.63. All right, as far as the video is concerned, we are at 11 o'clock right now, so I am going to shut down. But you can look on the notes I saved online, because we did a few more example problems in my third period when I saved those notes. Okay, thanks for watching the video. And hey, people watching the video, if you're curious, here is your homework assignment.
I love homework.